আমার পেন ড্রাইভের কাজ হয়ে গেছে।
হ্যাঁ, পেন ড্রাইভের বাইরে রেখে দিস। হ্যাঁ, আমি আমার ওখানে সেভ করে দিই। সবাই চলেছে, যারা প্রেজেন্টার তিনজনই আছে, যে চেয়ারম্যান আছে। তো শুরু করতে না না টাইমে রাপোর্টিয়ার কে তুমি রাপোর্টিয়ার তুমি ইয়ে ভেরি গুড রাপোর্টিয়ার তোমাকে সব জড়ো করে রাখতে হবে।
হ্যাঁ গৌতম, তুমি আমার কথা শুনতে পাচ্ছ?
হ্যাঁ হ্যাঁ,
গুড গুড, ঠিক আছে। সান্যাল সাহেব কেমন আছেন?
এসে আছি, ঠিকই আছে।
না না, আপনি ভালো আছেন, আপনি সবসময় ভালো থাকবেন। এই যে কৌশিক, এই যে কৌশিক, কৌশিক আপনার প্রিয় কৌশিক। কৌশিকের বাবা মারা গেছে কদিন আগে।
ও
এবার সাউন্ড অফ করে শুরু।
চেয়ারম্যান তো
আছে ডক্টর মালাই চক্রবর্তী থেকে আসবে। আচ্ছা
হ্যাঁ আছে, মানে
ভিডিওটা অফ করে দেয়। রেডি এবারে স্ক্রিন শেয়ার করে দিন জাস্ট ওয়ার্ক হ্যাঁ স্ক্রিন শেয়ার করে তারপর
ये फाइल अर्जेंट है ये लेके जाइए ठीक है। अभी मेरा एक मीटिंग है बीसी है अभी एक आध घंटा जो है मैं कुछ दूसरा कुछ नहीं कर पाऊंगा।
সকলেই বাড়িতে করছে
বাকি তো অফিস করতে রাখতে তো বাকি
দেখলাম যে অফিসে দেখুন টেকনিক্যাল গ্লিচ হয় তখন মুশকিল হয়ে যায়।
আমি কত দূরে রাখেন
ঠিক আছে আইএ ব্লক
हेलो
সেটা ভালো যে এখানে আলাই উনি সাজেস্ট করবেন পোস্ট লাইন প্রথম সেশন
আরো একজন জয়েন করার আছেন না? হ্যালো
हाँ सर
আরো একজন জয়েন করবেন না?
Now, 3 persons are there in this session.
না স্যার, সান্যাল সাহেব, গৌতম বসু আর আমি আছি, তিনজনই স্পিকার আমরা।
তপব্রত সান্যাল,
হ্যাঁ হ্যাঁ হ্যাঁ,
উনি আছেন।
গৌতম
আছেন।
বসু। আচ্ছা ঠিক আছে,
গৌতমও আছে, আমি আছি, আর সান্যাল সাহেবও আছেন।
আচ্ছা ঠিক আছে, ওকে ওকে। আমরা কি স্টার্ট করব না আরো ওয়েট করার আছে?
স্যার টাইম হয়ে গেলে স্টার্ট করে দেব। একটা 10 3টা 10 থাকে।
3:10, আচ্ছা ঠিক আছে। তাহলে আরো কত 1-2 মিনিট আছে? হ্যাঁ
হ্যাঁ স্যার টাইম তো হয়ে গেছে, আরম্ভ করতে হবে। Good afternoon everybody. I am Dr. K.K. Mohanto, rapporteur of this session. This session is for theme 3 and session 3, that is about geotextiles, and chairman of this session is Dr. Malay Chakravarti, Malay Chandan Chakravarti, Jute Commissioner, Kolkata, Ministry of Textiles. Basically, he is Indian Defence Account Service, IS Allied, Additional Charge Secretary, National Jute Board. Now I request Chairman sir to proceed the session.
Good afternoon to everyone.
Good afternoon.
It gives me immense pleasure to be associated with such an important event like this International Symposium on the Transforming Coastal Zone for Sustainable Food and Income Security, being organized by the Indian Society of Coastal Agricultural Research through video conferencing mode. This technical session 3 under the theme 3 of the symposium is focused on jute geotextiles and its application in coastal ecosystems. We all know that jute is an agro-based, natural, eco-friendly, biodegradable fiber. That is the biggest strength of jute. India, we know, produces about say 65 to 80 lakh bales of jute per annum, and more than 4.5 million people are dependent on jute for livelihood. Of course, this year the production has been adversely affected due to extreme weather conditions, including the cyclone Amphan. I mean, this year means I'm speaking of the financial year. But this event, the cyclone Amphan and the severe floods which took place in Assam and parts of West Bengal was probably an outlier. I'm sure this was an outlier event, and I hope that it is not repeated in the current year, and I'm sure it will not be repeated. So we all know that apart from its wide use in the packaging sector, jute in the form of geotextiles has emerged as a very potent civil engineering item since the last 3 decades. More than 800 successful field applications has established its efficacy in road construction, slope stabilization, river bank protection, railways, forestry, and many other things. The products have been standardized and now included in the standard schedule of rates. The guidelines on application have also been published by the Railways and the Indian Road Congress. My colleague, Dr. Pradeep Chaudhary is here. He has been constantly poking me on the efficacy and applicability of jute geotextiles, and I have learned quite a few things about JGT from him. It's a very interesting subject, and I really cannot claim to be, I mean, not even, I will not even use the word expert. I cannot claim that I know much about it. But I'm sure the experts here will enlighten us further on this topic with their deep knowledge and erudition. And let me tell you, I mean, I am very embarrassed to be given the title of doctor. I don't have a PhD. My maximum knowledge has been up to the level of master. So please do not talk to me about as a doctor, because that I feel always, once you get that doctorate degree, it has to be earned. It cannot be just given, thrown away like anything. So in this session, there are 3 eminent invited speakers. Shri Tapobrata Sanyal will speak on application of synthetic geotextiles for protection against coastal erosion. Shri Pradeep Chaudhary will speak on efficacy of jute geotextiles in mitigating soil-related problems, along with a few case studies. And Shri Gautam Bose will speak on protection of soil erosion of earth embankment using natural fiber-based composite structured geotextiles. Each speaker will be allotted 18 minutes for presentation and 2 minutes for discussion. I am now pleased to invite the first speaker to deliver his lecture, Dr. Tapobrata Sanyal. Dr. Sanyal? It will start with Dr. Tapobrata Sanyal or Dr. Bose?
No,
Dr. Tapobrata Sanyal.
Okay.
Tapobrata Sanyal.
Dr. Sanyal, please come in.
Yeah.
This one.
Presentation. Sir, is it visible?
Yeah, it is visible.
Sir, please. Sir, I'm asking.
Sir, before starting, let us see Engineer Tapobrata Sanyal's biodata. Engineer Tapobrata Sanyal graduated in civil engineering from Calcutta University, Bengal Engineering College, now IIEST in 1961. He had his in-service training in Netherlands as a government nominee in river engineering in the specialized field of geosynthetic applications. He headed the river research wing of Kolkata Port Trust as the chief hydraulic engineer 1992 to 2000. He was a member of West Bengal Senior Service Engineer prior to joining the post service. He also served as the chief consultant to National Jute Board, Ministry of Textiles, Government of India for some time. He is acknowledged as the leading expert in river engineering in the country and pioneer in the field of geotextiles. He is the first to author a book on application of jute geotextiles titled Application of Jute Geotextiles in Civil Engineering, published in Springer. His book on the river Hooghly in Bengali is a pioneering work, Hooghly Nadir Gati o Prakriti. He is a fellow of Institution of Engineers and member of several academic bodies in India and abroad. He was also the recipient of Cambridge Certificate for Outstanding Engineering Achievement. His name figured in Mark's Who's in Asia 2012 second edition. He was awarded Lifetime Achievement Certification from International Geosynthetics Society for his outstanding role in the field of geosynthetics in 2006. He has contributed more than 60 technical and research papers and international journals and has received a number of awards for his achievement. Now I request Tapurvato Sanyal sir to continue his presentation.
I just start my talk on the subject is application of geotextiles for protection against coastal erosion. That was the subject chosen by Dr. H.S. Sen when he first proposed and invited me to give an invited lecture on this subject. Now, application of geotextiles or protection against coastal erosion especially. And as you all know, protection of coasts against erosion is a critical component of coastline management. Human efforts to protect eroded coasts in the past did not sustain, as such efforts were based mostly on instinctive skills and practical experience with available natural implements without ascertaining the causes behind erosion. With the invention of geotextiles, coupled with the knowledge gained about the causes behind coastal erosion, it has now been possible to protect coasts against erosion more effectively. I must say that this seminar, ISA seminar, webinar, is intended for agricultural scientists and researchers and fiber technologists. But I am a professional civil engineer, so I will deal with this subject on the perspective of geotechnical aspects and hydraulic perspective. The main causes behind coastal erosion are waves driven by wind and storm surges resulting out of tectonic disturbances such as tsunami and waves caused by big ships veering past the coast. Offshore structures close to shore also cause reorientation of current and wave direction towards coast. Disposition of oceanic currents directed coastward and their celerity, plus littoral, that means along shore, and tidal fluctuation. In fact, oceanic environment is highly dynamic, demanding flexibility in design of coastal protective measures. Geotextiles, let me explain what is geotextile. Geotextiles are basically breathable planar fabrics made of either man-made fibers or natural fibers such as jute or coir. I will confine my presentation to man-made geotextiles made of thermoplastics such as polyamides, polyester, polyethylene, in view of the fact that natural geotextiles get biodegraded in exposed saline ambience quicker than the desired performance life which the design demands. The other aspect regarding natural geotextile is about porometry, or apparent opening size of the fabric, which coarse natural fibers cannot achieve as precisely as their synthetic counterparts. In fact, porometry is a critical criterion for effective filtration function of any geotextile. It may be mentioned that geotextiles for coastal protection use not as fabric only. Various innovative forms of geotextiles have since been developed, produced according to severity of erosion. Usually, geotextiles are applied in or on soil to improve its engineering performance. Engineering performance implies developing adequate capacity of soil to remain stable under impact of different kinds and degrees of imposed forces. Geotextiles are basically act as change agents that help build up effective stress.
I think we have lost you.
No, it will come, sir. Just a minute.
Engineering performance implies developing adequate capacity of soil to remain stable under impact of different kinds and degrees of imposed forces. Geotextiles act as change agents that help build up effective stress in soil, on or in which they are laid. Effective stress is a condition when resistivity of soil against import loads is stretched to the maximum. This is achieved by ensuring soil compactness as a result of effective filtration. The first trial with synthetic geotextiles was held in the Netherlands in the late 1950s for protection against ravages of coastal erosion caused by waves of the North Sea. This presenter self had the opportunity to witness a part of this trial. The success of the trial led to other developed countries coming forward to use the material for coastal protection. Now, synthetic geotextiles are used worldwide as a potent erosion protective material. Now, the special features of synthetic geotextiles are long durability, high tensile strength, and adaptability to manufacture customized fabrics in bulk at affordable costs. The main functions of any geotextiles are separation, filtration, and reinforcement. Natural geotextiles lag behind their synthetic counterpart in all the above features. The severity of erosive forces in coasts demand uncompromising compliance of the above features. In fact, there are three factors. First factor is durability. Second factor is tensile strength. Third factor is the fiber fineness, which will make possible any geotextile to conform to the desired apparent opening size. But in respect of some natural geotextiles, I personally worked in the field of jute geotextiles. I know there are some limitations of natural geotextiles because I'm speaking about synthetic geotextiles in view of the fact that the erosive forces in the coast, sea coast, is very severe. And we cannot make any compromise in design of a geotextile. However, what are the innovative forms of geotextiles? Sand-filled geotubes, geotextile containers, multi-layered filters or polyfelts, and rope gabions. These variants are used in flow regulatory offshore structures. After analyzing the precise causes of erosion in the coast, geotubes filled with suitable granular materials such as sand are used as cover apron on seabed. Geotubes are also used as component of groins or spurs or dikes. These are offshore structures. Large volume geocontainers are sometimes used as components of offshore structures also. Dikes or embankments are constructed sometimes by stacking sand-filled geobags one above the other in stable geometric shapes. Rope gabions are used as protective barrier against waves. In India, such innovative uses of geotextiles have not taken off in a big way. There are two principal types of geotextile that are used in conventionally woven and non-woven. This is known to all geotechnical people. Woven geotextiles are used for separation, filtration, and reinforcement, while non-woven geotextiles supplement or improve filtration function. Woven geotextiles possess higher abrasive, puncture, and tearing resistance and tensile strength than its non-woven counterpart. Non-woven geotextiles score over woven types in respect of permeability. In coastal erosion, sometimes both the types are used in conjunction in cases where strength and filtration are both called for. For a geotextile to perform effectively, it needs to satisfy mechanical, hydraulic, and durability criteria at sites. The long-term behavior of a geotextile against mechanical stresses in a site-specific hydraulic environment is pre-estimated in a laboratory. When the fabric is underlain by stone concrete revetment to withstand the initial impact of erosive forces, including uplift caused by seepage flow, care must be taken in selection of stone boulders and concrete blocks in regard to their individual weight and specific gravity. The main purpose is to ensure that geotextile doesn't get displaced due to erosive forces. In extremely severe cases, additional structural interventions such as groins, breakwaters, spurs may be needed to ensure repulsion or reorientation of currents and drifts away from the coast. Lawson, in a paper in 1992, mentioned two essential mechanical criteria. These are mass per unit area, and the number two is trapezoidal tearing resistance, for which there exist ASTM standards. Additionally, flow orientation and wave regime at the site need be taken into consideration. The type and nature of coastal soil also requires to be looked into. The nature of coastal soil material will determine the desired along plane and across plane drainage capacity of the geotextiles to be selected, which is called transmissivity and permittivity in geotechnical parlance, through prior laboratory tests. In fact, selection of the right product of geotextiles and control of material quality and execution are critical. For coastal protection, it is advisable to adopt a conservative design. There are two aspects: clogging and blocking. The geotextile may get clogged. That means inside the geotextile, there may be deposition of sand or other particles. And blocking is superficial coverage, blockade of the geotextiles. And for woven geotextiles, that's why porometry, or the apparent opening size, permittivity and transmissivity, tensile strength are important. And clogging and blocking of woven geotextile susceptibility may be determined prior to application by conducting gradient ratio test, this is ASTM D5101, or hydraulic conductivity ratio test, ASTM D5567. Synthetic geotextiles do not possess foolproof eco-concordance. That is a major disadvantage, which is why natural geotextiles are being increasingly favored in cases of less severe technical requirements. Despite limitations in regard to eco-compatibility, effectiveness of synthetic geotextiles in protection of coastal erosion, I especially stress on the term coastal erosion, of varying degrees of severity, firmly stands established. It is also what explorers, my suggestion is that we must explore if mangroves in the coast can be nurtured concurrently with synthetic geotextiles to protect coastland against erosion. Mangroves with the stilt roots can hold the coastal soil and at the same time can induce accretion of silt over coast when silt-laden seawater passes through their root system, besides attenuating the wave impact. There are about 64 varieties of mangroves with varying degrees of salt tolerance and growth rates. It is advisable to consult experts to decide on the choice of the right type of mangrove species for a particular site, depending on the salinity, depending on the soil type. Perforations may be made in the geotextile to plant mangroves to them. This is just a suggestion and demands in situ trial. In fact, in Port Trust, when I was in Port Trust, I was instrumental in setting up a mangrove interpretation center in Nyachar Island, opposite Haldia Docks. But the full research could not be completed. Before that, I was transferred. Thanks for your attention. This is all what I want to say. But I must say that The natural geotextiles, what Mr. Dr. Gautam Bose has in his subject has said, that is a structured geotextile with composites, synthetic and natural bend. Whether this can be effective in coastal erosion of moderate severity can also be looked into seriously. But geotextiles, jute, I worked with jute, and I'm very much supportive of jute, but for coastal erosion, I'm apprehensive. So that's my concluding remarks. I thank you all, Mr. Chairman, especially for conducting this seminar. Thank you very much.
Thank you, Dr. Sanyal. Your discussions, your viewpoints remind me where I was for some time looking after the charge of textile commissioner in Mumbai. I had met a few of these organizations who deal with synthetic geotextile, and I would tend to agree with you, because there is no doubt that synthetic geotextile should be able to probably would be able to withstand the severe pressure of the seas. And I've seen some of the demonstrations which was given to me. There is no doubt that jute will probably not be able to withstand to such extent. So, but two things which I would like to point out is that one is the eco-compatibility issue still remains, and as we know, the oceans have been, clogged, are getting totally clogged with plastics. So we do not know. Mankind as a whole does not probably have an answer as to how to balance the two. Yeah, and the second issue is the use of mangroves. I was posted in the Andaman Nicobar Islands for almost 3 years. So during that period, I have seen how mangroves basically are a great resistance against the fury of nature. I am told that the places where the mangroves were in a better shape, those places were able to withstand the tsunami of 2004 in a much better fashion. So, this suggestion of use of mangroves and GT combined is a very, very interesting suggestion. Now, may I request my colleague, Dr. Pradeep Chaudhary, to speak on efficacy of jute geotextiles in mitigating soil-related problems, along with a few case studies.
Thank you, sir.
Sir, before starting, just I read the biodata of Dr. Pradeep Chaudhary. Pradeep Chaudhary did postgraduate course in jute technology from University of Calcutta in 1974, and later on become the fellow of the Institution of Engineers. He worked in jute industry for 5 years and thereafter joined Indian Jute Industry Research Association as technologist in the year 1979 and worked there till March 2016 as principal technologist. In April 2016, he joined National Jute Board and has been pursuing the research and application of different types of geotextiles, agrotextiles. Some of his research achievements are unique method of jute bag manufacturing, development and successful field application of JGTs of width up to 200 centimeter and tensile strength up to 40 kilonewton per meter, and development and application of lighter simplified plain Weaver JGT of tensile strength 25 kilonewton per meter and 20 kilonewton per meter. Development and application of jute saplings bags for growth of saplings in the nurseries. He has published more than 130 papers in national and international journals, proceedings of conference. He has also 5 patents in his credit. More than 800 technical presentations have been given by him in different seminar conference, engineering colleges and academic institutions. He has awarded UNDP Research Fellowship and undertook advanced research and development work on jute composite in FTL, Wisconsin University, USA. He has been honored with Dr. Triguna Sen Award in 2007. Also has been facilitated as an engineering personality in 2015. Outstanding contribution in the field of geotextile engineering by the Institution of Engineers. Now I request Dr. Pradeep Chaudhary to continue his presentation.
Good afternoon, respected Chairman, sir, and all the distinguished audience. It's my pleasure to share my experience on the effectiveness of jute geotextile in mitigating soil-related problems. I was requested by Dr. Shane to share some case studies also. So, what is jute and jute geotextile? Jute is a natural eco-friendly bast fiber. India produces about 1.7 million ton jute per year, where more than 4.5 lakh people are directly or indirectly engaged in this field. Geotextile is the fabric which enhances the engineering properties of soil when applied in or on soil. Natural geotextile like jute geotextile, that is JGT, deserves separate mention because of its natural resources and annual renewability and also unique features. There is hardly any differences between the synthetic and natural geotextile function-wise. So there are some unique selling points of jute, why it has become so popular. There's a very strong high tenacity, high initial modulus. This is a very, very important factor. At low elongation at break, there is a hydrophilic property, unique hydrophilic property. It can absorb 5 times dry wet moisture. And also eco-concordance, renewable resource, helps reduce carbon footprint, construction work. And also the advantage is abundantly available. My dear friends who have not seen jute plant and the process, have a look here. This jute plant is a rating, this is a jute plant, fiber is extracted. Thereafter, through the mechanical processes, this type of fabric are being manufactured using the existing machinery in the jute industry. There are several types of jute geotextile, oven, non-oven, open structure fabric, and jute sapling bag, which has been developed and applied successfully all over the world, I should say. Chemical constituents of jute, it is lignocellulosic fiber. That's why hemi and alpha cellulose is very high, more than 82%. So this slide, I think, will give some problem. Anyway, in this slide, I have shown that it is the initial modulus is very high, so that it has made suitable for use again, for suitable for geotechnical applications. Anyway, that is not being showing. So yeah, these are the technical specification of different type of jute geotextile. This is for riverbank erosion control as filter fabric, and this one 724 GSM fabric that has been developed by us. It's at tensile strength of 25 kilonewton, both machine direction and cross direction. Whereas in the riverbank protection as filter fabric, it is 20 kilonewton, having the porometric range between 150 to 400. That matches with the most of the particle size of the soil. 760 GSM open jute geotextile that was also developed by us, having the 21 kilonewton tensile strength, has also been used successfully all over the country. And thereafter, the open structure fabric, open weave it is called. These are the three main varieties of JGT has been developed by us and standardized and has been included in the schedule of rates of RDS, of BRO, and also the Indian Railways. And this fabric is the jute sapling bag fabric. BIS standard has been established. The IS standard is there. It is 272 GSM having these technical features. Now, you will be, all of you listening or seeing these slides or presentation will be very happy to note that jute geotextile products has been standardized by BIS. All the 5 standards have already been standardized by BIS. Research, Design and Standard Organization of Indian Railways, they have also prepared this guideline. Unified Standard Schedule of Rates has also been published by Indian Railways in 2011 that help Indian Railways, all the 17 division of Indian Railways, excepting Metro Railways, they are using jute geotextile in huge scale, large scale. Indian Road Congress, that is the most powerful body, the road engineers follow their guideline. So after standardization or publication of all these standards, this is the standard guideline for the design and construction of low volume rural road using jute geotextile, IRC SP 126 2019. That is the latest achievement. We worked hard and the success came that IRC has accepted it and published the IRC code. That you may call it a Bible of the road engineers for using jute geotextile for construction of rural roads. And schedule of rates, PWD, WSRDA, irrigation, PWD of Assam and Meghalaya, BRO, and all other 17 division of Indian Railways, they have included, we have standardized it in their schedule of rates. So the jute geotextile is a biodegradable material that is known to all, including the speaker himself, that after some point of time, it will degrade and mix with the soil. But why we are working with jute geotextile? Sanmal Sahab has rightly said that everywhere jute cannot go, but in many of the cases, jute geotextile is very effective because, you know, the findings of the renowned engineer scientists all over the world, what they found that percentage elongation at break of JGT is significantly lower than synthetic geotextile, which is more than 50%. Whereas in jute, it is around 15% maximum. Substantial reduction in rod depth under dynamic condition with using of JGT. Ramesh Shami of Singapore State University, he found it. Ramesh Shami Sahab also found that loss of strength of jute geotextile after a year is not a deterrent, as by that time, jute geotextile is seen to have helped in providing a self-sustaining condition for the most type of soil. So we don't bother about the biodegradation. That is the only question asked everywhere, all over the world, wherever I travel or Sanmal Sahab has traveled, the same question asked. And answer is that no, not a technical deterrent. Also, Jadavpur University Professor Nitin Shom, he also found that gaining strength of the subgrade of the road with time is compensated with the loss of strength of jute geotextile. So, my dear friends, we need not bother about this. Here, this slide shows that there are 25 states in India who are using jute geotextile. Encouraging results achieved from extended R&D work help scientific significant increase in demand of jute geotextile. As of date, more than 800 successful field application has been done in the country and elsewhere. My dear friends, as of now, so long the products are found to be highly effective in normal soil and climatic conditions. Interestingly, it was also found equally effective in difficult soil with high salinity, up to 30 ppt in and around Sundarban area of West Bengal. The areas of application in this zone are construction of Ayala affected flood embankment, road construction in Pathar Pratima, that is also Sundarban area, and elsewhere. About 9 roads has been constructed. River bank protection work at Jagatdal River Kakdeep, growth of mangrove seedling and sapling at Canning, Basanti, and Gosaba. Also, construction of rainwater tank at Sagar Island. That is the most important thing. Our government has taken the initiative. Now, I would like to show you some case studies. How should I believe? Saying a good words is not enough. Show the results, then one can believe it. But reconstruction Ayala affected flood embankment. Name of the work: reconstruction of about 980 kilometer flood embankment in Sundarban and adjoining areas in North and South Chobbish Pargana of West Bengal, damaged by severe cyclone Ayala in 2009. Under Sundarban Embankment Reconstruction Project, Irrigation and Waterways Department, Government of West Bengal took this project. Total 98 sites at Joynagar, Kagdeep, Busaba, Basanti, Sonakali, etc. of South and North Chobbish Pargana district. What is the objective? Reconstruction of 6-meter high earthen embankment with the use of 500 GSM open structure jute geotextile, followed by grass tarping for stabilization of the slopes of earthen embankment to protect the land, houses, population, etc., and to arrest inflow of saline water to the mainland of the area. Features of the embankment were height was 6 meter, angle of slope, very gentle slope, 2:1, and slope length was, it is the angle of internal friction. Depending on that, it was 2:1, and slope length was about inclined length about 12 meter line. My dear friends, this is the simple method of laying jute geotextile on the prepared slope. This is it is available in the form of roll or bale, whatever it may be. It is rolled down to the slope and anchored onto the ground with the help of nails, all these things. So, what done? The surface of the slope was first dressed and leveled. JGT was laid side by side on the surface with an overlap of 10 centimeters and fixed onto the ground with the bamboo pegs or iron nails, whatever is available. Top and bottom ends were anchored in the trench, dug at top and bottom line so that it is not being dislodged due to rain or grass sods and seeds was sprayed, followed by occasional water. Result and discussion. At the end of 6 months on application of jute geotextile, the slopes of the embankment were found to be sufficiently stable and the entire surface was covered with vegetation. Similar process was adopted, restored the entire flood embankment in phases. Interestingly, my dear friends, based on the encouraging results in ILA project, Irrigation and Waterways Department decided to use jute geotextile for reconstruction of 322-kilometer stretch of flood embankment damaged by another super cyclone Amphan at Sundarban and adjoining areas. They will take our support and will do that. This is a pictorial view of the ILA embankment. This is the embankment. Eroded slope is vulnerable to erosion. Jute geotextile was laid on the ground, on the slope, anchored properly, and thereafter, after 3, 4, 5 months, the entire area was covered with vegetation. That is the most interesting thing. Another work was done in road construction. In Sundarban area, total number of 9 roads have been constructed. However, this road is recently under construction. Up to WBM layer has been constructed. Strengthening of the weak roads upgrade from Pushim Sripati Nagar to Akure River at Pathar Pratima in Sundarban area. Location, it is in K Plot Island, South Chobbish Pargana. Objective, what was strengthening of the weak subgrade with the use of oven jute geotextile. Work done, sorry. No. Yes. Work done. The existing brick layer, there's a primary, that is the pre-work condition. The existing brick layer was removed from the unpaved road, about 4.2 kilometer length, surface and compacted with power roller after filling with the local soil. JGT was laid onto the compacted subgrade longitudinally with a sideway overlap of 10 centimeters, overlain with a thin cushion of sand, 25 millimeter thickness. Granular subbase of 1 and 2 layer, 100 millimeter each, was applied. There were also laid prior to applying water-bound macadam layer. Finally, it is to be as of day before yesterday, this layer was done. And within 1 week time, finally, it will be finished with 20 millimeter thick premix carpeting, followed by 6 millimeter thick bituminous seal coat as a wiring coat, that is riding surface. This is the way of method of applying jute geotextile in between the subgrade and subbase. Subgrade, this is subbase. This fabric, so that it doesn't penetrate, intermix with the construction material. So pre-work characteristic of the subgrade, it was the maximum dry density was 18.7%, 1.68, and Optimum moisture content of the soil was this, respectively. Plasticity index was varied between 18.36 to 99. While California bearing ratio, that is load bearing of the soil, was measured to be 3.3%. Observation: post-work study was conducted by the engineers of West Bengal State Rural Development Agency when node distress of the treated road, that is the up to WBM layer, was noticed. The top surface was perfectly smooth. Excavation is scheduled to make near the edge of the pavement for collecting soil sample for the subgrade below the JGT layer for testing at the laboratory. Conclusion: what we conclude? Average severe value of the subgrade before application of JGT was 3.3%. The subgrade is supposed to gain strength significantly as were found in more than 200 cases in India by application of jute geotextile. Lot of works has been done in Bangladesh, India, where we have found that on application of jute geotextile, severe value, practical field, it enhances by 3 times, around 3 times. It is what mentioned that total number of 9 roads has been constructed in the remote areas of the Sundarban area with success. This is the precondition of the road. Bricks were removed, and after laying the sand, after placing the sand, this subgrade was compacted and then jute geotextile was laid all along. Thereafter, this GSB material has been laid, and this is the condition laying the granular subbase, WBM layer was laid. It will be WBM, not GSB. Sorry. Okay. Next, river bank protection work was also done in Sundarban area. Restoration work of severely eroded right bank of the river Jagatdal at village Uttar Surendraganj under Pathor Pratima block using treated jute geotextile under Kakdev irrigation division was done. Uttar Surendraganj village at Pathor Pratima block in Sundarban area, this is the location. What is the objective? To control the erosion. Severely eroded bank was controlled with the use of JGT, treated JGT. Feature of the site was 400-meter vulnerable bank of the river located at around 15 kilometer away from the Bay of Bengal. The river was tidal in nature and the bank soil was mostly clayey silt. Due to drawdown effect during recession of the both high and low tides, the bank soil naturally tends to flow down to the slope, river causing severe erosion. The impact of the wave that Sanal Sahab was mentioning, impact of wave that hugs to the bank soil was also another cause of erosion. Salinity varied between 7 ppt to 20 ppt of the site. My dear friends, this is the method of laying of jute geotextile. This is the dress slope has been prepared and fabric was laid. And here in this case, instead of boulder, brick was easily available. So brick block was done as a armor to cover the fabric so that the fabric stay intact on the surface, on the slope surface. Protective measures taken with JGT. Treated JGT was laid as filter fabric on the prepared bank slope to prevent migration of the soil particles from the bank and also for providing escape routes to the confined water to neutralize the differential overpressure. JGT was covered with brick block as armor. This covering material. Results: no sign of erosion was noticed even after elapse of 2 years. And Pradeep Datta was there as assistant engineer. He spoke to me about 1 year, 1 or 1.5 years back. He told that no, that is the entire area was excellent condition. No sign of erosion has been observed. Average siltation over this period was estimated to be around 20 centimeters over the armor. Most of the treated area was covered with vegetation, which ensures stabilization of the bank, river bank, with the use of JGT. The undisturbed bank after 2 years implies that jute geotextile performed its designated functions and helped in natural consolidation of the bank soil. Durability of jute geotextile beyond 1.5 years, even under persistent flow adversity, tidal flow, two-way flow, proved to be redundant due to catalytic function of JGT. This is the condition of the eroded bank. You can see the severity of erosion. Jute geotextile was laid and armored with the brick blocks. After 2 years, this picture was taken by us and supplied by irrigation department. And this is the condition. You see the entire area. This has been transformed to this. So biodegradability of jute geotextile is never a technical deterrent in most of the study. For what? Use of rainwater harvesting tank. That is a unique project government has undertaken all over the state, all over the country. They are doing this. Slope protection of road and growth of sapling. This work, slope stabilization of the rainwater harvesting tank, slope stabilization of the road embankment, and growth of sapling using jute sapling bag. It was done in Ganga Sagar Bokhali Development Authority at Sagar Island. Rainwater harvesting tank at Benubon, road from Chiangumari jetty to Benubon, and jute sapling bag within the premises of the GBDA was done by a GBDA, that is Ganga Sagar Bokhali Development Authority. The objective was to stabilize outer slopes of the rainwater harvesting tank for arresting inflow of the saline water in the specially designed tank for storing rainwater meant for fishery and public utility, all these things. Second, to stabilize the vulnerable slopes of the road. And finally, last one is the growth of sapling using jute sapling bag. Nature of soil predominantly saline in nature. Soil texture is mostly clayey and saline, which hinder growth of normal vegetation and free culture. Future features, what is the dimension of the tank is 200 meter, breadth 27, and depth of the tank was 2 meter. Because this feature, why I am showing this, because this is, there are every possibility to erode the bank so that the erosion could be checked with the use of this one. Feature of the unpaved road, it was 800 meter long and angle of slope was 2:1. Type of JGT used, that 500 GSM, same type of fabric was used here also and was used in the rainwater harvesting tank also, the same type of fabric in the Ganga Sagar. Work done in both rainwater harvesting tank and road construction. JGT was laid on the slope surface with an overlap. In the similar process, I am not repeating this. And interestingly, our honorable chairman sir and sorry, you are talking about the mangrove. Okay, here what we did is the adverse climatic soil condition specially suggested to use vetiver grass instead of normal grass. So in between the holes of the fabric, South Indian variety of vetiver grass was planted and the slopes through the openings of the JGT, considering the salinity of soil and the quality of road, survival rate. Watering was done occasionally. The seeds of lembu, that is called probably shegun, in Bengali we call shegun, botanical name I cannot remember. Seeds of lembu, that's a local language, planted in soil filled with 2,000 pieces of jute sapling bag of this dimension for raising seedling and growth of sapling, followed once daily. After 6 months, the grown-up saplings were transplanted directly onto the designated ground without removing the jute cloth. That is the advantage. Within a period of 4 months' time, application of JGT, the slopes of the embankment were found to be sufficiently stable, and the entire surface was covered with vegetation at both the sides. That is the rainwater harvesting tank and road slopes. The performance of the jute sapling bag was also found quite satisfactory in respect of growth and survival rate of the seedling and sapling. The grown-up sapling, where it is most interesting part, the grown-up sapling were transplanted directly onto the ground without removing the biodegradable jute bag after a period of about 6 months, unlike polybag. Here you can see the picture, how this was done in the road slope. Is the vegetation growth, mangrove, sorry, not mangrove, is the vetiver grass, length and root, everything you can have a look. Here also the rainwater harvesting tank, the slope was protected with, treated with jute geotextile and growth of all these things. You can have a look here. And here you see that Ganga Sagar Bokhali Development Authority, they use the jute sapling bag, seeds inserted in the soil filled with bag, growth of seedling first, thereafter coming up, that is emergence of sapling has started, then it was transplanted onto the ground. Next slide. Yes. Last case study is the sapling bag for mangrove plantation. Mangrove is a unique plant, and that can elude our respected chairman sir and Shanal Sahib, both of them mentioned about this. Name of the work is a growth of mangrove using jute sapling bag for plantation in coastal area under Mahatma Gandhi National Rural Employment Generation Scheme. Location was different location: Canning, Basanti, Gosaba in Sundarban area. To use eco-friendly biodegradable jute sapling bag for better growth and survival rate of the mangrove saplings, discarding the use of environment pollutant polybag to maintain eco-ambience in the area. Features of the jute sapling bag: standard Hessian fabric of as per BIS standard. This was used and cut and stitched in lock stitch sewing machine, industrial model sewing machine to make bag. Out of total 13 lakh bags applied by Jute Corporation of India, 5 lakh was prepared with gray fabric having dimension of 9 inches by 6 inches, while the remaining 8 lakh with size 5 inches by 7 inches. So, work done. Seeds of mangrove were sown in the bag, filled with soil, and allowed to grow seedlings and also to grow as saplings. After about 3 to 4 months' time, the grown-up sapling were transplanted to the designated ground along the coastal side. Results: within a period of about 4 months' time, growth of seedling and sapling was observed to be highly satisfactory in respect of growth and survival rate. The grown-up saplings were then transplanted directly onto the ground in the coastal area without removing the biodegradable jute bag after a period of about 4 months. Why? Because it will mix with the soil and form biomass. Biomass is nothing but added nutrient to the soil. That is the added benefit of jute. Based on successful field trials, MGA REGS authority decided to manufacture jute sapling bag locally to ensure employment generation for the poorer section of the local people society with the technical support and guidance of Jute Corporation of India and National Jute Board. My dear friends, this pictorial view you will definitely enjoy. The women, poor women, they are inserting these seeds inside the sapling bag, placing the growth of seedling started, growth of sapling, then transplanting this sapling on the proper designated site, and finally this is the result speaks. Chakraborty Sahib, that is our JC Sahib, chairman of the session, was telling that he has seen, Shanal Sahib was mentioning about this. This is the thing done using these biodegradable jute bag. Biodegradable is a blessing, not curse. Thank you very much. Thank you for your patience here.
Thank you, Dr. Pradeep Chaudhary. We have given a comprehensive presentation on the efficacy of jute geotextile in mitigating soil-related problems, along with a few case studies. We have touched upon the USP of jute, the specifications of such geotextiles, then properties of natural fibers versus synthetic geotextiles. Then we have touched upon the standards and guidelines of quite a few organizations have now evolved guidelines on JGT. BIS is there, RDSO is there, IRC is there, then SSRs have been published by many states. Then some salient research findings we have shared. Then almost we have informed this house that about 25 states are using JGT. Then you have also flagged the issue of use of JGT in adverse and climatic conditions, and you have gone through quite 5 detailed case studies where we have understood that JGT is also a very potential, a very, what should I say, a very eco-friendly and a very with vast possibilities for in the field of geotextile. I thank you, and then let me move to the last speaker of the day. Dr. Gautam Bose, I think, is here. Dr. Gautam Bose will speak on protection of soil erosion of earth and embankment using natural fiber-based composite structured geotextiles. This is again a very interesting subject. I would request Dr. Gautam Bose to kindly start his presentation.
Sir, before starting, just the biodata of Dr. Gautam Bose. Dr. Gautam Bose is the former principal scientist and head Mechanical Processing Division, ICR NIRJAFT. He did masters in textile technology and completed his PhD in polymer science and technology from University of Calcutta. He is fellow of Institution of Engineers. He has published nearly 100 papers, including research, review, training manual, lecture notes, in addition to 6 books and 13 book chapters. 4 patents have been awarded to him and 2 others are under process. His 40 years of work experience includes 9 years of industry and 31 years in research institute. His major areas of work are investigation property of natural fibers and their value addition, improvement in process performance of natural fibers through various pre-treatments, technical textiles including geotextiles, and development of machinery and testing instruments. He has a member of various recommending bodies on natural fibers found by government or agencies. He was involved in 28 research projects, including principal investigator of World Bank and Government of India funded projects. Now I request Dr. Gautam Bose to proceed.
So, respected chairman and our audience,
Sir, please share the screen.
is it visible?
No, sir. First, open your presentation in PowerPoint mode. Yes, sir, it has come.
Now it is visible, no?
Yes, sir. Please continue.
Yes. Respected chairman and my other dignitaries and audience, I'm presenting one of my work, the protection of soil erosion. Successful work is the protection of soil erosion of earth embankment using natural fiber-based composite structure geotextiles. Mr. Sanal is a very experienced in this hydraulic engineer and very experienced in this region, in this aspect, and he has elaborated the problem with the jute geotextiles for the in some cases, and also there is some problem of the synthetic geotextiles also. In our work, I've tried to assimilate both the good things of both the materials, synthetic as well as jute. So by then we have structured a geotextiles, we have manufactured a geotextile, we designed a geotextiles which can be suitable for both type of land structures and land types. Mostly it is already built. All the genesis of this work is the bioengineering of the soil structure using geosynthetics, one of the major methods. And mainly the products are used by PP, HDP, polyester, already been mentioned. And all this material is basically the specification of these raw materials, highly location specific. And the advantage of the synthetic geotextile that had been already been discussed. I am not going elaborating these things again. High durability and lightweight also, high stretch. But some problem with it, synthetic geotextiles, major problems is a low modulus. It's a very low modulus material, which is really sometimes pose problem in the structural engineering or the in case of geotextiles and structural engineering. And another problem is that, and nobody is highlighted, is the slippery nature. So placing or laying of this material on the earthen structure, the earth structure, it's really sometimes problem for the, especially for the soil erosion protection, and create phase separation. The synthetic create phase separation between two soil layers. So plantation or flora and fauna that can be destroyed because the structure of the geotextile is supposed to be 100% covered, though it is not 100% actually, but it's supposed to be 100% covered. The flora and fauna is destroyed and the vegetative growth is not possible in this way. And then another thing is the polyolefin, which is lighter than water. We know the density of the polyolefins is 0.9 to 2.95 is like that and less than water. So it is try to float above the water. So in the water prone area where I have to lay the fabric, at the place the fabric is was the problem. Now, what I wanted to, what I tried for these, I searched I saw the problem of the synthetic geosynthetics, 100% geosynthetics, and being a jute and an Institute of Natural Fiber, scientist of the natural fiber, I searched, but we have the expertise on this natural fiber. So I found out some some positive points of the 100% geotex, 100% natural fiber, and which had been assimilated in the single product. So how could we resolve this problem? It is known that no single element can provide all essential quality characteristics of the final product. It is known to everyone. No single element, either 100% synthetic or 100% jute. Lot of problems are there. For jute, 100% jute, a lot of problems are there, already been discussed. And about the synthetic, I already been discussed in the previous slide. And natural fiber, jute, coconut, and synthetic in our work, that has been used together to minimize the disadvantage of component fiber in incorporating their complementary advantages. So let us see in very brief what point I have emphasized about the advantages. So many advantages are there. Mainly, I took the advantages of the tensile modulus and greatest dimensional stability. It's a very good dimensional stability of the jute fabric, which lacks in case of synthetic. Most of the cases, most of the synthetics, lignin helps to strengthen or stabilize soil structure. The jute contain more than 15%, 20% lignin. So that lignin, remnant lignin, strengthen the soil structure. It is heavier than water, so underwater work is no problem. It is anti-slip in nature. Everyone knows it. That is why it is very much successful in deck production, deck sackings and others. So anti-slip in nature. And everyone knows that the natural agro-renewability. Main problem is early biodegradability. But being a jute technologist, I have take this early biodegradability as an advantageous feature for the present structured geotextiles. It is not being a problem. I've used this as an advantage in the new product. What is another fiber I have also been used? That is the coconut fiber. This coconut fiber is a high durability, very, very high durability, and very high lignin content also.
I think you are not audible.
Probably he has lost the connectivity.
Please check, please check.
Is my presentation is visible now? So there are some problem with the connections.
Yeah.
Is my presentation is visible?
No, sir. Please share your screen.
I have to again share night. I have to again share it here. Okay, mute. Is it now?
Yes, sir. It
Sir,
is. Yes.
is it? It is not. Okay. Sorry for the interruption. The constitution, I'm quickly going through the parameter of the material, the parameter of the product, their construction, the plain width, that is basically union fabric. In warp is the PP and HDP flat tape, that is with 2.5 millimeter. Everywhere it is available in India. It is being used in the warp direction. It's a linear density was used to 111 to 2000 text, depending upon locations. That is the location to make the product, the location specific product. So I have used this fabric in 2 places in Bengal. In one place it was used 111 text HDP and other was 200 text polypropylene. It was a jute, and quality ratio of the jute was only 75 to 80. Linear density of the jute is 900 text, and mesh density in 39 and 46. And peak insertion rate, you can see, sir, there is a peak insertion is 420 per minute. So we are making a jute fabric having its jute content is 80 to 85% with the peak insertion in such a high rate. That is the beauty of this product, one of the beauty of the product. This is the look of the cloth. In workway, it is apparently completely closed structure. Apparently, it is completely closed structure. Nothing is visible on the side. And if you see the area density, it is about only 330 per meter square. So where the jute is 85%, GSM has been reduced like anything, so we could reduce the transportation cost also. And jute coconut fiber, jute and coconut fiber and PP was 60 to 40 in the initially. Thickness 1.5, and other specification I already discussed. And you can see the blend ratio of 86 to 14 in the 10 kilonewton cloth, and it is 20 kilonewton cloth. It is 83 to 17. 17 is the synthetic part, and 83 is the jute part. So in the total GSM 83%, and synthetic part is only 17%. You can see 20 kilonewton cloth could be made, and the apparent opening size, it was 178 or 180, 178 and 180, well within the control of the American standard, US standard, ASTM standard, well within this standard, 178. Puncture resistance and trapezoidal tear resistance, whatever mentioned by respected Mr. Sanal, that was also well above the ASTM standard. And another beauty of this product, you can see, sir, if you see the load elongation curve, you can see the synthetic part, that is dotted line, the modulus is so low, and jute having the high modulus. And after blending, which of the very high work of rupture, that is synthetic is a high strength, high elongation, ultimate result is a high work of rupture. But after blending, we got the work of busting strength, work of rupture by busting, it is much higher in case of blending. It is another beauty of this new product. And this is a the dotted line is for the synthetic, 100% synthetic, and this is for the blended. And quickly I'm going over the case study. I've taken the two case studies. One is where river water is not always touching the embankment, and another case study where water is always embracing the river bank. It is in Bengal, in the district Birbhum. It is a sectional diagram of the geotextiles. For everyone, all the geotextile technologists can understand these things. It's very easy. It's the embankment. It was dressed as per the specification, as mentioned by Dr. Pradeep Chaudhary. It was just well dressed, and then it was geotextiles were laid in this way, and then the grass sorts. It was the geotextile was covered by the grass sorts only, and you can see the work. And this was and simple things was a bamboo, locally available bamboos and other locally available materials were used to anchor the cloth. And the geotextiles are covered with the grass sorts. And you can see that after 3 months, the work was started on 6th June 2007, and it is after 2007 work. And after 3 months, it is the work of your look like this. And sir, after 4 months, it's June, July, August, September, yes, after 3 months, there's a huge rain, if you remember 2007, and that time was the rain was about 290 millimeter within 5 days. And water was released from the Tilpada barrage and Messenger Dam, and subsequently from Tilpada barrage, and total water flow was there 1,65,000 cubic. In this rate, you can think about this rate, and water was reached up to this length, only 1.5 meters was left at that time. And if you see up to this height of the water was reached, and you can see where the geotextile was laid. This is the picture where the water was laid, the geotextile was laid, and you can see the part where geotextile was not laid and where the geotextile was laid. It is on the right side, it was clearly seen that geotextile laid bank, and other side is geotextile not laid. And somehow it has been saved. And you can see the extent of erosion in the bare slope, untreated slope. You can see the extent of the erosion, and you can see the protection of the bank with the geotextiles. And the data was that geotextile treated bank, no rain cut within the 100 meter, whereas untreated were the 64 rain cuts. And other parameters you can see over here. It is about 700 centimeter depth, and width was 700 also. And after 1 year, sir, this one. And our concept, if you ask, how could I use the jute and synthetic showed so much successful? Actually, the concept was that in the initial 2 to 3 months, as the rain goes on, there will be the fine soils particle will be deposited at the back of the geotextiles, where the jute and synthetic have been made. Nearly apparent opening size is 180 only, and on days go on, after 3 or 6 months, the jute part will be mixed with the soil. It will rotten. It is mixed with the soil, and there will opening size will be increased. Then the root will be distributed like that. You can see. You can see. So top layer of the soil and bottom layer of the soil are being reinforced by the synthetic structure. I can show you, that is our concept, how it has been reinforced. And I'll actually show you You see, in the lab stage, the jute has been degraded and the roots have been penetrated to the synthetic part, synthetic network. That rhizome, the upper part and stolons are there, the bottom parts, and it is been interlinked naturally and made a very good structured three-dimensional structure. It's a very good three-dimensional structure, dense structure with the soil. And you can see the synthetic part is there after 6 months, and no jute is available, no jute is observed, only coconut fiber is being there. But jute is essential. Jute was essential for the initial 3 to 4 months. It was essential. If it is not there, that it could not be successful. Jute is essential for the 3 to 4 months. But it is not that the only jute can protect everything. Your synthetic network should be there as a reinforcement, as we use the iron structure in my concrete. It should be remain there, though it is a network structure. And where the synthetic part has been it was compared with the 100-year composite structured geotextile and with the 100% conventional geotextiles. You can see the condition. Soil has been slipped off and torn off by the cattle hooves. You cannot stop these things. Grass sorts have been slipped and scattered vegetation. This is a major problem with the 100% synthetic geotextiles, which has not been observed in this case. And in the second case study, is more interesting. You can see the picture of the embankment before treatment. It was a fruitless effort was made by the local authority, and they took our help to protect this river bank. It is where water is always embraces the bank. And you can see the before treatment. And the location is at the Rampurhat area. Slant length was 14.8 meter and slant angle 30 degree by 40 or 245 degree. It is not equal. With embankment on the top is 2.6 millimeter. And another problem was that when during the high tide, the water is seeping through the embankment. That is another problem. And this was the structure. I can show you better the original picture. It was the polyjute strap cloth has been laid like this. Here two trench has been cut, dug out, and cloth has been taken from the inside of to guard the toe of the river. And you can see the picture of the whole cloth has been laid. And upon that, the coconut rope net has been laid. It's a coconut rope laid. Why a coconut rope laid has been laid? Because this river is susceptible to face 12 to 13 flash flood every year. 12 to 13 flash floods. So whatever silt being deposited, that should not be washed out during the successive flash floods. That is why to arrest the silts, that was laid. And it was not a very costly matter. And one unique feature has been used, that is seamless cloth sand bag has been laid. Seamless. It is 40-meter long bag. There is no stitch, neither side nor in the bottom or top. Seamless. So you know the seamless fabric has got 2 times or 3 times strength with seamed cloth. So we have got with the same raw material, we got a stronger sand bag, geotextile tube with the circular cloth. And you can see this circular cloth as a length of tube is 40 meter and mass of sand of elliptical geotextile tube. It is a moist sand. It was 137.34 kg per meter square, sir. Only whose minor radius is 12, minor diameter is 12 centimeter and major diameter is only 70 centimeter, having 137.34 kg per meter. This is another novelty in this work. And the soil was covered, that the geotextile was covered, and it was after the full 6 months covering one full monsoon, we can see. And after 3 full monsoon, no deformation was observed. Vegetation started to grow. Thickness of the filter cake formed 3 centimeters at the middle of the slant. Filter cake means the layer of the soil behind the geotextile that was cut carefully and it was measured. And soil retained within this network sand, it is 196 gram. Thickness is 1.5 centimeter. And you see, after a year, encountered 3 flash floods. Nothing was there. Every year they used to face the flash flood 13 to 12 times, and every time was washed out. Was usually being washed out, and it was not been washed out after 1 year. And it is after 3 years. Full vegetative cover has been established. Fully covered. And after degradation of the jute, sir, it has the engineering data, the bioengineering results have been given. After degradation of the jute, openness of the synthetic backbone, on the synthetic backbone, 137%. So very good breathability for the soil, flora and fauna. Gap of the thread interstices increased from 0.27 millimeter to 1.34 millimeter. And we know the girth of the root of the grass we have measured is 1.5 to 0.9 millimeter. It was used by Japanese vernier. And vegetation density, it is 77,500 units grasses per meter square. And growth of earthworms was also visible. In case of 100% synthetic, it is not visible. And withdrawal force of the single grass from the soil at instant tensile test tested, it is 8.5 Newton. And so total withdrawal force, it is a tremendous, it is 659 kilonewton per meter square. Huge strength. And it is simply made by the bioengineering. And soil retained at the coconut net, it is 212 kg per meter square as compared to 88 kg per meter square where no net was laid. And the thickness of the soil hard cake formed due to the geotextiles measured by the carefully cutting out the 3 parts of the slants, that is 70 millimeter thick near bottom, 50 millimeter thick at the middle, and 40 millimeter thick near top. And conclusion, sir, this is my 1-page conclusion. There is a grass turfing along with jute, coconut fiber, and synthetic blended geotextile reinforcement has proven its excellence in protection of the rain-fed riverbank in the absolutely sandy soil, maintaining the soil flora and fauna. And the full package of practices from selection of the raw material to batch mix to the application of the end product is available. And thank you, sir. Thanks for all.
Thank you, Dr. Bose.
Yes, thank you.
This has been a very vigorous session. I think we are now almost at 4:40. So this almost ran for around 1 hour 30 minutes or 1 hour 25 minutes. So
Yeah.
Dr. Gautam Bose spoke on the protection of soil erosion of earth embankment using natural fiber-based composite structured geotextiles. He spoke of the genesis, the synthetic geotextiles, its advantages, the problems, how to resolve the problems. Then he also spoke about jute and allied lignocellulosic fibers. He compared coconut fiber vis-a-vis jute, parameters of the composite structured GTs, physical parameters of optimized jute synthetic composite in geotextiles. Then he analyzed the tensile behavior of geotextiles. Then lastly, he flagged 2 very interesting case studies. One is where placing of geotextiles were water not always embracing the embankments, and the other where it was always embracing the embankments. So, I found these two simultaneous cases very interesting, and thank you from the House for bringing such interesting case studies to our notice.
Thank you.
Are there any questions, or we can proceed to the last remarks? Any questions, any queries from the House? I think since there appear to be no further queries, I'll give my concluding remarks if everyone is in agreement.
That's
Yes, sir. Yes, sir.
I must thank Dr. Sanyal, Dr. Chaudhary, and Dr. Bose for their presentations and bringing out their erudition and their vast repertoire of knowledge gained over 4 or 5 decades of practice as well as research in front of this House. I have been asked to give certain recommendations at my level. From where I am seeing things, it might be very difficult to give a clear technical solution for everything. You have much more experience and knowledge in this regard, and for myself, without having any substantial depth of knowledge, it would be probably wrong on my part to flag complete solutions to everything. But then I can only point out that there are solutions for every situation, including using both synthetic geotextiles and jute geotextiles, or even composite geotextiles. All three have been flagged in this session, and we are still learning as an organization, as research activists, as users. We are still learning, and based on our lessons we have learned from the inputs we have received from various projects, I can only suggest that whenever such problems are presented to us, we must build on whatever are the lessons or the learnings we have from previous projects and try to find the optimum solution. There could be situations where the synthetics could be probably the optimum solution. There could be situations where the jute geotextile could be the optimum solution, and of course the third, of course, could be where the composites using jute geotextile, using jute could be the best solution. We will have to work within these solutions and try to use whatever are the best for that occasion. And but at the same time, I must, during Dr. Sanyal's presentation, I spoke of the need to think of the environment. We must always also keep this in mind, so that the minimum use of synthetic fibers or synthetic materials are applied for solution to such problems. That is my earnest request. I do not know whether you must be knowing that the havoc that plastic is causing. We already have that Great Pacific Garbage Patch. I do not know, many of you must have read about it, which is bigger than the size of the state of Texas, which is floating around in the Pacific, and people are hardly able to find a solution for this. I follow quite a few environmental channels on YouTube and other places, and I am seeing the havoc that is being caused to not just humans. It is also the the animals who are part of the entire food chain, the ecosystem, are getting badly affected, and it will ultimately break the natural cycle. So we will have to take all these into consideration before into a solution. I thank you all and my to the complete conference. Thank you.
Thank you very much.
Thank you very much, sir. Thank you.
On behalf of ISCAR, I thank Chairman Sir Dr. Malay Chakravarti and other distinguished speakers for giving lectures very nicely and conducting the session in a nice way. Thank you, sir.
Thank you. Yes. Okay. So, you're fine again. হয়ে গেছে কৌশিক শুরুটা করে